portal now? Yes. So coming to our next speaker, Mishmak. Hi there.
Hi, Swati. How are you?
Yes. Now we have Mishmak. Hello.
Can you hear me?
Yes, I can.
Great.
All
So I'm
right.
gonna try. I'm gonna try and
Yes.
share my screen.
Presentation. Yeah, let me give a
Oh,
brief introduction about Mish. She is the head of marketing at Additive Engineering, and today she'll be talking about a topic which is kind of very much close to my heart, and I'm really passionate to know that how much does it cost to print this? I mean, it's the question everybody asks. So I'm glad that Mish is here for us today, and she can probably answer all our questions. So the floor is all yours, Mish. Feel free to share your presentation. Thank you.
not sure I can answer all your questions, but I can try. Let me just try and share my screen right now. All right. Can you guys see my screen? Okay.
It is visible.
No news
Thank
is good
you.
news. All right.
Yep.
So thank you for your interest in this presentation. How much does it cost to print this? Okay. Before and I think this is what Swati has said, this actually topic would be relevant because it's actually one of the most common questions we get asked as a 3D printing service provider. Before I start, I'd like to recognize the first people of this nation and their ongoing connection to culture and country. We acknowledge the First Nation peoples as the traditional owners and custodians and law keepers of the world's oldest living culture. Today I'm presenting from the Bunurong country of the Eastern Kulin Nation, and I pay my respects to elders past, present, and emerging. Okay, about the presenter, what can I say? I know her very well. I've worked with more than half the 3D printing companies in Australia and the APAC region. Currently, I'm with Additive Engineering. We are an Australian-based company specialized in 3D printing medical implants and aerospace products. Okay, so how am I qualified to answer this question? My first degree is in finance, and also because the world needs more female engineers, I'm also doing my third degree in advanced manufacturing. So I will have industry solutions that won't break the bank, and hopefully some useful tips that don't get covered enough in engineering school. Some disclaimers: if you have a desktop printer at home, chances are the prices I'm going to tell you is not going to be cheaper than DIY because most of us just do not factor in the cost of our time. The prices are quoted in Australian dollars, and they're only meant as a guide, so do not hold me to it as an official quote in any way, okay? And pictures that you see are sample parts. The copyrights belongs to all respective owners, so no confidential information has been shared here. So I thought I'll set the stage for you. The additive manufacturing landscape, if you don't know it already, is pretty complex. Okay, as of 2021, there's 194 original equipment manufacturers across 5 rough areas of materials: metals, nylon, composites, ceramics, and hydrogels. So today I'm only going to cover 2 broad areas, which is metal and plastics. And specifically for metal, I'm talking about powder bed fusion or direct metal laser melting, as GE would call it. Specific to nylon, I'm talking about selective laser sintering. So if you find this chart familiar, you would probably have spent some time like me trying to find answers to the cost of 3D printing versus traditional manufacturing. And what I really disagree with this chart is that straight line that you see for additive manufacturing. And the reason why I say this is because there are many factors actually impact the cost of additive manufacturing. So for example, from experience, a few is always cheaper than a one-off. Geometry of the part. How many can you nest in a printer? Which leads to the next question. How big is your printer? So obviously, the bigger the printer, the more you can nest and the more parts you can manufacture in one full build. And when do you need it by? Do you need it yesterday, today, a few months' time? They all actually add to the factor of what price you can actually 3D print a part for. And what material would you need it in? Most people come with already a material in mind because it's a replacement of something else. But the next question is, what kind of mechanical properties do you need it? And is there an alternative we can provide you as a solution? And do you need post-processing as a requirement? So these are just some of the factors that actually impact the cost, the unit cost of additive manufacturing. So in summary, it's not always a straight line. So this might be an interesting chart. It actually shows across nylon printers. Not all nylon printers are the same, even though if you look at the data sheets, you know, two different technologies could have exactly the same tensile strength. But remember that data sheets are representations of new machines. The age of 3D printers would also tell you whether there's actually whether the mechanical properties would be the same, because lasers degenerate over time. Some different companies do different powder refresh rates, and also there are post-treatments that actually can improve the parts' mechanical properties. So just looking at this chart itself, EOS and HP seems to have a similar tensile strength. But what we've found with a client who actually did some internal fatigue testing is that the parts printed actually were 15% stronger in terms of their fatigue testing compared to what they've used previously. So this gives you an example that, you know, the same tensile strength may have very different mechanical properties with different printers and different technologies. So how much does it cost to print? Now that we've set the stage, the following are actually 7 examples that I'm providing across different industries. Hopefully one of them is relevant to something that you do. Okay, the automotive industry. Everyone loves to talk about cars, right? At least the people that I hang out with. An Inconel valve cover. We got asked to quote for an Inconel valve cover for a car. Would you consider CNC machining or 3D printed? That's one of our eternal questions. So specific to this, before I get even to the prices, if you don't know what Inconel is about, it has a pretty high melting point, pretty similar to stainless steel. It's heavier though. It has higher temperature resistance and oxidation resistance. It has much better. It holds its loads much better at higher temperature, and it has also extraordinary resistance to salt water as well. So to 3D print an Inconel valve cover, a one-off piece is about $10,000. To CNC machine the same part would cost $11,000. So fun fact, Tesla replaced their steel main battery pack with Inconel to increase maximum pack output, to increase in acceleration for their ludicrous mode. So maybe there's actually some advantage to look at Inconel for some high performance applications. But if you don't have $10,000 to spend on your car, there are aluminum valve cover equivalent. It only costs $1,800 in aluminum for a complex design. So I would say a pro tip for you is if the materials are difficult to CNC machining, it's very likely that it will be cheaper to actually 3D print it. And I thought I'll show you an example of an off-the-shelf aluminum valve cover, which is not to spec, but it's actually quite similar to the 3D printed price of a more complex specified valve cover. Okay, so if you don't have a car and you have a bike, you might be interested in titanium bike hooks. Bike dropout hooks are one of the things that's 3D printed in titanium because of its strength to weight ratio. This is a relatively small titanium bike dropout hook. The solid titanium dropout hook would have cost $1,250 just to 3D print one. So we save further weight by removing the internals and replace it with a lattice structure. That brought the price down to $427. The same lattice structure part could be printed in stainless steel for $160. fun fact, if I print the lattice structure for the titanium for about six of them, I can be pretty cost competitive to stainless steel. And that's just an example that I've mentioned about how when you print multiple parts, it's almost always cheaper than a one-off part itself. So besides the cost itself, the solid titanium bite hook was 56 grams. And after I applied a lattice structure, I saved about 70% weight savings. So this is, and if you are a bike enthusiast, right, you would love the idea of weight savings. And on top of that, if you compare titanium to stainless steel, titanium has the same amount of strength as stainless steel, but at 40% of its weight. So this is a huge advantage when you compare, two different materials doing the same, trying to do the same thing. So for example, if the pro tip here would be, yeah, you can actually go for the cheaper material, but ultimately weight saving benefits also leads to other advantages when it comes to life cycle benefits, not just for bike hoods, obviously, but for other applications where it's applicable. All right, aerospace, it's kind of like the holy grail of 3D printing. So when we talk about, when your part can be 3D printed for aerospace, you've made it, right? This is a good example. I spent a lot of time going down a rabbit hole of material science research, and this is actually one of the ones that I actually really like. It's done by Aalto University in Finland in 2018, and it compares 3D printing of an aerospace bracket to CNC machining. So just looking at the, just looking at the workflow itself, you can already see that 3D printing itself is a more streamlined process, which means time savings, less complexity when it comes to the supply chain, right? Next, you look at the original GE aerospace bracket, which is traditionally CNC machine, which is a huge block, 1 kilo, 231 cubic meters. And then you look at the advantages of 3D printing, right? You can do a topologically optimized redesign of the same bracket at a fraction of the weight. So with this comparison, this is actually the price. The comparison was done across batch sizes of 1,000 and 10,000. So the unit cost is not that different between CNC machining and AM. But if you look at the buy to fly ratio, which is one of the properties that we measure for aerospace, for every 1 kilo of part in CNC machine, you really waste 1.8 kilos, versus for 3D printing, for 1 kilo, you waste 150 grams. So the buy to fly ratio significance is huge. And on top of that, you have design freedom as well. So design freedom allows you to optimize the weight, which then again leads to savings in fuel consumption. So one of the things that this 2018 paper talked about is you really need only 6 brackets for additive manufacturing to become more competitive than traditional manufacturing. But I did a comparison of just 1 bracket today, and CNC machining is already costing more for 1 bracket as compared to 3D printing. So again, this only adds the advantage that there are certain applications that 3D printing is actually more cost effective. Okay, now to something a little bit more fun. If you are into sculptures, we got asked to manufacture a giant pig. This pig is not that little. It's essentially 1.2 by 1.6 by 1.2 meters. It was designed to be CNC machined, and we did some comparisons, and the cost to 3D print it in aluminum was $28,000. It would have been 3D printed in 10 parts, and then we'll have to assemble it together. Well, sounds like a lot of money, but then I did a little bit of digging, and I found that a simple round aluminum sculpture made of wire starts at $40,000. Okay, and so I thought, oh, maybe $28,000 is not that expensive for a 3D printed pig sculpture. And then I found a second-hand aluminum shark is selling for $22,000. So this pig is a bargain if you think about it. You know how intricate is the design that you want, and the fact that it's 3D printed to your specifications. The only catch I would say is the file took me hours to process because it was solid, because it was made for 3D. It was made for CNC machining. So if you are if you're an aspiring artist out there and you're really looking to explore 3D printing for your artwork or sculptures, make it hollow if it's applicable, because it will save a lot of time, weight, and cost. So that's the pro tip here. Moving on to consumer products. I can't tell you what a consumer product is, but this is actually part of a tool. And consumer products tools are used for injection molding. So this is one of a two-part tool that needed to be manufactured. So to manufacture it, to 3D print it in stainless steel would have cost $16,000 and would have weighed 10 kilos. We couldn't do CNC machining with this, but because if you look carefully at the drawing, there's actually conformal cooling channels, which actually helps to improve the productivity of injection molded tools, and the plastic products that comes out of it has much better surface quality as well. So we actually got a quote to compare to 3D printed in aluminum overseas would have cost $30,000. Again, there are possibly cheaper alternatives. We could potentially 3D print it in tool steel, but this is actually a discounted price because 3D printing companies would offer discounts if they're currently using a specific metal in their 3D printers and they don't want a hassle of changing materials to do one job. So the pro tip here is, if you can, ask if there's another material that's on offer that is currently running on the printers, which can also do the same job. So that way you could actually, take advantage and get a somewhat better price as well for a higher quality material. Architectural models. It's kind of a dirty word in our industry. It looks fairly innocent, but small part, it just costs $100 to print, but that's not the end all. At the end of the day, a lot of the designs tend to be resized from a full-size building, as you can imagine. A lot of the resizing cause issues with the part being able to be 3D printed. So what happens is a lot of times we have to spend we have to spend cleaning up the data. Once we've scaled down the model, we have to ensure that the mesh is printable. So it's not just, if it costs this amount of dollars to manufacture, if I'm shrinking down to 1/10 of the size, the price should be just 1/10 of the price. It's not just that. It's like there's actually a lot of time spent in cleaning up files in order for it to be printable. So that's something that you need to consider as well. If you can do it yourself, that would be best. But a lot of times people just send us a file and go like, can I print this giant model in 1/10 of its size? So the time spent that is quoted is actually the time spent in cleaning up the model even before we 3D print it. So that's a pro tip for you as well to consider. So like I mentioned, additive engineering specializes in medical. So when I say, do you know what's the price of a model of your skull? It's not a Halloween trick question. It literally is the things that we print on a daily basis. So why would we need to 3D print models of skulls? It's pretty much used in surgical plannings for surgery. It's printed in PA 2200, which is a biocompatible, sterilizable nylon, and it comes with material certification as well. So this specific bio model of a person's skull costs $280, and it's also meant to test the fitment of the titanium implant that you can see on the skull itself, which costs $650. So really, all in all, they contribute to accurate patient-specific implants. All these things add to a more successful surgery, and at the same time, patient-specific implants can halve the recovery time of patients. So then they can regain their quality of life, which, you know, if you need to put a price to it, is really priceless. So there you have it, my 7 examples. I have to do a little plug so you understand where I'm coming from as well about additive engineering. We are, like I mentioned, an Australian-based 3D printing service provider. We are considered an SME, founded by Hugh Tevlin. That's the guy with the expressive hands in the picture. He has more than 10 years of additive manufacturing experience, and started up this facility based on just some customers' feedback that there's just not enough quality medical 3D printed products in the market. So within 6 months, we got ourselves accredited for ISO 9001, and also had to pass 13485 production standards for a medical customer, which is essentially 9001 on steroids. Currently, we have 6 industrial 3D printers, 2 CNC machines, and 1 heat treatment furnace. And like I mentioned before, all our technology materials are certified for both medical and aerospace products. And not just that, we've actually had quite a lot of experience working with medical implants as well. One of our biggest partners is Leica Smith. They are manufacturers of more than 5,000 patient implants for surgery. The same technology we have from GE has also printed the NASA Poggle Z baffle, which has an amazing lead time reduction from 9 months to 9 days. And specifically for aviation, you know, we like to talk about the fuel nozzles, which are FAA approved, and are flying in Airbus A320s, Boeing 737s. There's 100,000 of those things flying in the air and have accumulated more than 1.5 million flight times. So this shows that this technology is both suitable for one-off patient-specific implants and also repeatable airworthy products as well, which is what you need in a high-quality production 3D printing technology. And specific to we are also DISP certified, which just means that we've passed the governance, personnel, physical security, and cybersecurity that allows us to supply to the Department of Defense. I'm not going to go through all these, but basically we have the ability to print cobalt chrome, Inconel, titanium, grade 23 specifically, Hastelloy and stainless steel are just some of the examples of the high performance materials. We do get asked to print aluminum and stainless steel 316. They are probably more common, but we like to show the high performance ones just so that people consider the other materials that are available out there. So this is actually quite a good example which shows what actually drives the metal 3D printing market. And every time I present this slide, I get different answers. A lot of people would guess it's automotive or aerospace, but not many people realize that it's actually medical and dental that drives the metal 3D printing market. So what does this mean? I mean, it just means that because we are in the medical space, all the other customers who are in the other industries can take advantage of medical's economies of scale to access very high performance materials and the 3D printing technology itself. So I think in conclusion, if you need some help on production quality 3D printing, or just want to know if you've got a bargain or if your deal is too good to be true, you have an additional person to call. And if you like my presentation, please go to LinkedIn, follow Additive Engineering Australia. And we try to put out very interesting industry stories, not just about ourselves, but in the spirit of sharing. It's a lot more on what the industry is doing, specifically in high performance material as well. That's it. Any questions?
Yes, thank you so much, Mesh. You can now stop presenting your presentation, and then we can quickly move ahead to the questions. So we have few interesting questions over here. And to be very honest, I was just amazed by the fact that how easily you were quoting the prices of each and every, medical parts, be it skull. And so we have a question related to that as well. Like, does additive engineering outsource its post processing? And if it does, how do you kind of accommodate that in your quotations?
So we do the post processing in house.
Wow.
Part of our medical procedures require us to do a lot of things in house. Having the and I actually forgot to mention that a very important thing is our turnaround for medical is 3 to 5 days. Sometimes it's 3 days because it's an emergency. So we don't have the luxury to actually post process by outsourcing. So a lot of times we have to do things in house. The only thing that we actually do not outsourced, but the sterilization sometimes is done by the hospitals themselves. So that's probably the one thing that in the future we will try to do it in house, but they prefer to sterilize it themselves at the current moment.
Wow. And I would like to understand that what are the factors you keep in mind? Suppose for your surgical planning, the skull which you showed us. So when the whole price, overall price, what are the factors you take into account apart from the materials, design, or maybe what are the, I mean, it should be a hint for all of us that what we should consider as a part of our cost when it comes to do a total overall cost quotation if we have to do that.
Um, it's kind of hard to say because a lot of our prices are automated by the volume and also by the expected amount of skulls we get. It sounds terrible, but essentially, we have, because we are kind of we do this on a daily basis. We've already worked out a sort of a workflow for our medical customers, such that once those come in, that's the price that they actually pay for that, because we also have expected volumes from them. If it's a one-off, the price could be slightly different. Like I said, one-off is always more expensive than a few. If you are a medical customer and in a year that this is X amount of skulls you'll be needed over past history, that helps us to work out a price for you, such that whenever you need to have a quick turnaround, we can actually be able to do that for you, if that makes sense.
Yes, actually, that answers one of our questions, which we have already, because the question was like, do you have different cost models for different industries? So, absolutely, it is. It is like clear. And addition to that, we have another question that how do you educate your customers to better understand the full end-to-end value of additive, beyond the just TCO, which is like total cost
Um,
of ownership. Yes.
Most of the time, everyone's busy, so I tend to say that if you can give me as much information as possible, that helps. And also, I like to start the relationship with understanding what they're trying to achieve as well. A lot of the people that we work with, they tend to ask the questions up front, so that we can give them those information, and they can actually make better decisions. So I think it's also a learning process for us, because obviously if they have past experience with different manufacturing processes, we need to learn, why are they not doing those processes anymore? Are they trying to save costs? Did it not is the mechanical properties not good enough? So then that way we can also adjust accordingly, because 3D printing has its advantages. It also has its disadvantages as well. So for example, if a customer comes with and wants like 10,000 parts, I will never say, hey, why don't you 3D print it? It doesn't make sense. It's never going to be as cost effective as injection molding, because that's where the price has really can be reduced to the tooling price, and also the manufacturing price is very low. So that's why it's a lot on understanding what the customer is trying to achieve.
Absolutely, that totally makes sense. And we will just quickly take our last question, which is like, how do you see the quality cost, as in internal failure cost, like low yield rate, appraisal cost in additive manufacturing, especially for high mixed, low volume production?
Um, I suppose having a facility with a specific certification for quality help, but at the same time, for aerospace and defense, there's something called DIFOT. For the life of me, I don't remember what it stands for, but I think it stands for defects that are delivered on time, and so it just means that you have to always prove that you are able to deliver no zero defects, and also your production delivery is on time. It's a constant continuous improvement. So essentially, not every part is suitable for 3D printing. So it's a little bit of experience and also understanding whether once you produce those parts, we have our internal quality controls. And if it doesn't pass internal quality controls, we don't send it out. There has been, obviously, with complex cases, sometimes it's also a learning experience for us. But the idea behind it is we have our own internal quality controls to ensure that the parts that the customer receives is of a certain standard. So that itself, like different industries will have different accreditation to meet those standards itself. So medical and aerospace are different. So it really depends on what kind of certification that customer needs for quality.
Wow, that's lovely. And one more question: do you do all the mechanical testing in house as well?
We don't do all the mechanical testing in-house, but we do have access to research and also testing facilities that can do testing as well. The good thing is we've done some ourselves, because when you do medical implants, there's always that worry that are we printing to the standards of what the data sheet is saying. Remember, when I say that data sheets are printed for new printers, and it's always, it's obviously done in certain conditions. So we've actually done our own internal studies to ensure that what we've manufactured meets the standards, if not exceed the standard. So that way it's a peace of mind for us as well, because, the last thing you want is for a medical part to fail. So that has been done ourselves. We don't share that information because it's proprietary, but we
All
can
right.
stand by the data sheet, that whatever the data sheet says, we have outperformed. If not, we have met the data sheet specifications for mechanical properties.
All right. With that, thank you so much, Miss.